Let's take a look at this example. This time we have rational function with the absolute value in the numerator. Before we are going to do anything, we're supposed to, like always, look at the denominator. Replace x by 4. 4 minus 4 is equal to 0. We said we do not want to have 0 in the denominator. So what we're supposed to do next, we're supposed to look at the numerator and check what we can do in order to eliminate uncomfortable denominator. In the numerator we have absolute value. In order to do something with the absolute value, you're supposed to remember the definition of the absolute value. Okay, so I'm going to apply right now this definition into my numerator. I have x minus 4, absolute value is going to be equal x minus 4, and I have x minus 4 in our case is going to be greater than 0, and I have negative x minus 4, and I have x minus 4 less than 0. As you can see, when we have absolute value, we're supposed to consider two conditions. When the limit is approaching 4 from the right side, and when the limit is approaching 4 from the left side. For x minus 4 is greater than 0, we're going to have limit which is going to approach 4 from the right side. And I'm going to have limit x is approaching 4 from the right, and simply replace the absolute value by x minus 4 over x minus 4. X minus 4 over x minus 4 is equal 1. So I have limit x is approaching 4 from the right side of 1. Limit of constant is equal constant. That's why this is equal 1. So limit approaching x from the right side, in our case, is equal 1. Next, I'm supposed to calculate the limit which is going to approach x from the left side. X minus 4 is less than 0. That's why I'm going to have limit x is approaching 4 from the left side. And I'm going to replace this time my absolute value by negative x minus 4 over x minus 4. X minus 4 divided by x minus 4 is equal 1. Negative divided by positive is going to give me negative value. So I'm going to have limit x is approaching 4 from the left side of negative 1. Limit of constant gives me constant negative 1. Let's take a look what we have obtained. We have limit approaching x from the right side is equal 1. And I have limit approaching x from the left side is equal negative 1. Because these two limits are different, that's why the limit doesn't exist. Let's take a look at this example. This one is a little bit different comparing with the ones which we just solved. We have limit with x approaching to 0, sine 3x over 5x. We're supposed to start, like always, from the denominator. 5 times 0 is going to give me 0 in the denominator. We said we do not want to see zeros in the denominator. So what we're supposed to do right now, we have sine in the numerator. If you want to do something with problem like this, you're supposed to use the fundamental formula for the theorem of limits. The formula is limit with x approaching to 0 of sine x over x is equal 1. You're supposed to realize that anytime we say x is approaching 0, so means x is getting closer and closer to 0. So if you are going to have constant multiplied to x, bx, so this expression is going to also get closer to 0. So if I'm going to rewrite this expression, sine bx over bx, so limit of this expression is going to also approach 1. So how are we supposed to apply this into our problem? I have limit with x approaching to 0 and I have sine 3x. In order to apply this formula, I'm supposed to make sure that I'm going to have 3x in the denominator, because I have x and x. I have bx, bx, so I have 3x, I'm supposed to have 3x. But this is not the end yet. You have to make sure that the bottom expression is going to be equal to the top one. I'm supposed to compensate this by the fraction multiplied to my original statement. I'm supposed to say 3x in the numerator, I'm supposed to have 3. Because I had 5 in the denominator, I'm supposed to have 5 in the denominator, because if you are going to reduce 3 and 3, you are going to end up with 1. 1 times 5 will give me original expression. So I can rewrite this as limit x approaching to 0 of sine 3x over 3x, because I have multiplication, I can have the product of the limits. So I have limit with x approaching to 0 of 3 over 5. Limit with x approaching to 0, sine 3x over 3x is equal 1. Why? Because sine bx over bx is going to 1. Limit of constant is equal constant. I have 3 over 5. 1 times 3 over 5 is equal 3 over 5. This is the solution to my problem.